My impression from John is that this is supposed to be hack time. We're working on stuff throughout, so I'm only going to start with slides to help frame frame the discussions and some of the activities or projects that we work on for the next couple of hours. And that's really fortunate because this presentation is really only half done. So once it starts to tail off, then we'll stop and then we'll get into installing it and running it. And we'll try to just juggle whoever is working on the different projects all at once. We can work on a single one as a group or break up into different parts. And that's fine. We'll just deal with that as we go. So my name is Tim Lebo. I am a third-year cognitive science student here at RPI and Tetherless World. And I'd like to talk to you about this conversion automation that I've been creating over the last couple of years that I call csv2rdf4lod. If you understand all of those acronyms, then that's awesome. We don't need to go any further. Unfortunately, even when you know the name, it's really hard to pronounce anyway, so we just call it converter. And the tagline here is long name, amazing results. I don't know if you guys have heard NewYorkHelpWanted.com's radio advertisements, but they're pretty amusing, and so that's where this comes from. So start with a skeleton, a ghostly outline that we're not going to work through entirely. I'd really like to just focus on the motivation here, why this tool exists, what it's doing, and then just focus on the first two aspects of the converter. The quick and dirty, talking about how we've really thought out how to naively bootstrap converting tabular data into linked data and RDF, and then talking about how really what matters here is not getting it to RDF and not making it linked data, but to making it good linked data and to making it useful linked data. And so that's where this second bullet comes in with time and attention, adding enhancements. And so before you leave tonight, I'd hope that you would at least apply one enhancement to see how that works, to see that cause and effect. And hopefully when you go off and work on your own projects and hopefully choose to adopt my tool, you'll basically have the intuition on how to do that so that you can look at the menu of all of the enhancements and pick and choose what is appropriate for your data set. And if not, then feel free to shoot me an email and we can figure out what's best for your data set. And then the stuff that I'm just going to kind of mention in passing, just to let you know that they're there. I'm going to dig into this stuff a little bit more in a month when I come back to talk about the advanced features of the converter. Provenance is built throughout all of the automation. So provenance is really important, and I'll talk about it when we get there. And recent developments over the last couple of months, especially inspired by the linking open government data project here at Tetherless World, is dealing with multiple users, multiple machines, and multiple data sets and how to manage that. And then finally, converting data is good on its own, but unless you know that you're getting the data that you want and you're still getting the data that you want, you're always in question on whether or not you are standing on solid ground with the demonstrations and analyses that you perform. And so I want to talk a little bit about how we actually perform some verification by using some Sparkle-based unit tests on the conversions, which is very, very important. So motivation. The world that we live in and the world that we're interested in for linked data, especially with linked open government data, is that we have just a variety of organizations, government agencies, non-governmental agencies, interested amateurs, whatever. They have data and they're providing that data. And once we get past this discoverability issue and we manage to figure out how to download all the data, then we have a pile of documents that really aren't interconnected whatsoever. This is where semantic web technologies comes into play. And so we have two entities kind of staring at this pile of documents. We have Peter's convention blockhead, this blockhead represents a computer. And he's standing next to the human, and they're both staring at the documents, and they don't understand what's going on. Neither of us understand how these things interconnect, what they actually mean. And that comes from a variety of reasons. It could be lack of domain expertise. You just don't know what they're talking about. It could be because whoever created the data chose some arbitrary abbreviation coding schemes that would be pretty obvious to a layman, but aren't because they're just codified, maybe to save some space or what have you. So how do we get past this issue, and how do we contrast that with the vision of having linked data in semantic web, so we can transform these documents into the big RDF graph. And the key aspect here is that we're no longer looking at the data as just kind of holistic chunks of data. What's key with linked data is that the individual data elements live on their own, and those individual data elements are connected to the other individual data elements independent of the particular document that you might be describing that data element. And so here we're fading away the notion of what a document is, and we're emphasizing what we're actually trying to describe, the representation of chemical analyses from EPA, facilities that are in our neighborhood. Those are the things that matter, not the documents that are used to describe them. And so we can contrast the blockhead and our humans staring at these documents that are very inquisitive about what's actually going on versus what we hope to be the case where both machines and humans can understand this data because it's highly connected, because it relates to how we approach and understand the domain that we're working within. And so really the converter automation tries to fill this gap. There's plenty of approaches to doing that, but I would, before we talk about mine, I'd like to just kind of motivate this with, we ran into a data element in these gray files, these holistic files, and so it's CHAD. If you found a data element that's called CHAD, what would you think it would be? Well, it could be the country, Chad, which has a URI on DBpedia, which is derived from Wikipedia, or I just went to semantic web dog food. Chad, if you're listening, here's your URI. We're talking about you. There's one of two Chads. Are you Chad?
No, hanging Chads.
Hanging Chads? Absolutely.
Is that what they were called?
Yes.
That's what I was thinking too.
See? No.
So
Is that
Hanging Chad
capitalized?
was one kind of Chad.
no. We're talking linked data. We're not talking ontologies yet. But I can point
is
that
Chad
where that fits in.
Uppercase Chad?
Huh?
So if it
Thanks,
was
Chad.
linked, it would still be hanging. That's correct.
You'd still be connected, right? All right, so the semantic web isn't necessarily about discriminating among these individual elements, although it does do that. It provides a universal identifier that can be used anywhere. But the more important aspect is that when we're these guys over here trying to do some analysis, we don't care about how you've referred to the country, Chad, that we might be doing some analysis on some foreign aid, which is one of the demonstrations on the wiki. All we want to be able to do is find the one URI that we care about, that actually represents the thing that we're analyzing, and then be able to work through the entire RDF graph and find some new information about that. We don't want to have to deal with the nuances of all the arbitrary decisions that the different source organizations decided upon when they encoded it within their arbitrary documents. So once we've transformed from these individual documents into the big graph, then we're able to do that wide-scale analysis just by latching on to a single URI that represents the thing that we actually represent. So we've abstracted away the individual nuances of the source data sets. And so if we look at another data value in the same file, kind of within the same context, if we see Cuba, then we can then see this discrimination. We're probably talking about countries and not people. But even in this situation where we could kind of squint our eyes and infer or abduce that these things are talking about countries. We don't want to have to do that kind of guesswork when we are kind of just processing all of these data. We want that guesswork abstracted away from the individual nuances so that we can just attack the data and do something useful with it. So we can hop into another example. Well, we've got a 15 here. This is one of the data values in the data files that we've obtained. And well, we could use the abduction trick with the last thing with Cuba and Chad, and I'll show you another data value kind of just hanging out there. Well, it's 14. Does that give you any more kind of information about what that is? Well, I'll give you a little bit more. At the top of the top of the table, the header is state. Now that you know these things are states, I'll even tell you it's the state of the United States, contiguous state of the United States. Well, 1 of 50. What is 15? What state is that? Multiple choice, you got 50 answers. Well, you don't care, right? You care that it's Hawaii, which is a URI that you can latch onto within linked data. And so we want to be able to abstract away all these nuances of the individual data sets and just tackle the data and run with it and do our analysis. And so 15 does represent Hawaii. It's called a FIPS code, but we're more concerned about the actual state. So in this situation where governments are scurrying to release their data sets through web pages and URL document downloads, and if we know where they all are and we obtain them, we're now stuck with this problem of that's a lot of data files. How do we go through the work of figuring out what everyone means? And if we're trying to create this big cloud, I'm not going to sit down and do all of that. And so really we're running into this economy of resources where we have all of these different source organizations that are providing data, and you have the same source organization providing multiple data sets. And when they're creating and releasing these data sets, they're also updating these data sets. And so you need to kind of deal with this temporal delta. And so you have these three principal attributes that you have to wrestle with. Who is providing you the data? What data set do they kind of refer to it as? And are they changing that particular data set? And so you have this proliferation across these three different attributes. And we're overwhelmed by that because we're low on the combination of these three guys, time, domain expertise, and semantic web expertise. So not all of us have all three of these that we would ever want. So how do we get from this proliferation of unconnected, unintegrated data documents into the big RDF graph that we really want? And so that's why I'm up here talking about this tool. So, and this is the gap that we're trying to fill. So I think that, well, my answer to that is csv to rdf4lod automation, which is a set of scripts that wrap around the core conversion. It's a Java jar, but the core converter, which converts tabular data to well-connected, well-structured RDF representations, guided only by a description in RDF on how to perform that processing. So the really nice thing about this is that you're not writing any custom code, you're writing an RDF description on how you want those tables to be interpreted to construct well-structured, highly connected RDF graphs. And so my scripting of choice is shell script, and so really it distills down into this retrieve, which is just go grab the data and edit some enhancement parameters, which really only ever involves adding a couple of lines because the template's already provided for you, and then just pulling what I call the conversion trigger, which actually converts the data, and then publishing it, which is storing it onto the web, throwing it into a Sparkle endpoint, a variety of different Sparkle endpoints. And so the automation is hosted on GitHub, on the GitHub project with the really long name, And here's the URI for the software. It's a DOAP software. And here is the URI for the OWL class of all enhancements that you could declaratively state within the enhancement parameters. So let's first start with talking about the automation and the integration stages on what you do when you obtain the converter. What you do when you obtain the converter is you start by installing it. And after you've installed it, you're up and running. First thing you need to do is have a data set that you care about, and you need to name it with only providing three attribute values. An identifier for the source organization that provided you the data, an identifier for the data set that source organization is calling their data set, and an identifier for the version. So you can just fall back to time. I got it today, or the mod date on the web file. And so once you've named it, you haven't done anything. You've just kind of said, hey, this data exists. And once you've named it and you can point to it, you can retrieve the data, which manifests a version. Because once you have this concrete data file on disk, you can then start doing with it and applying the enhancements. And if you don't want to apply any of the enhancements, then you can just produce the raw conversion and start working off of that. And so to create the raw conversion, you create a conversion trigger, and then you pull it, and then you get your raw data conversion for free, and then you can backtrack and provide in some enhancement parameters. And so this is kind of the workflow, the stages that you work through whenever you invoke any of the automation utilities. And here we have kind of the division between your local machine down here and then the web. So any action that you do or the result of any stage gets published to the web so that your results are available to anybody who chooses to poke around. And we start by retrieving EPA's government data set and then hosting all of our intermediate results here at RPI. So you walk through those steps and you really didn't do anything. All you did was provide identifiers for EPA, and you provided an identifier for, we'll go to identifier for whitehouse.gov, and then you identified an identifier, you provided an identifier for a data set. They have this visitor access records, which is pretty popular. So you just name name an identifier for that, and then they actually provided revision identifiers. They release them quarterly, so that kind of falls out for free. So you provided these three attributes, and you can get RDF directly from that. And the URI design that falls out of that raw conversion is thought out to ensure that we are distinguishing among data values from across all of those different sources, so that if the White House mentions a particular token, like Hawaii, that might be a different value than the EPA refers to Hawaii. A really bad example, but the important aspect here is that we're constructing the URI to disambiguate any of the values that any of the data sets ever refer to. And so the nice benefit here is that you don't have to think when you create the raw conversion, but the consequence is that you don't have any highly connected, well-structured RDF representation that is meaningful to anybody, which is why it's really important to enhance your data. And so I'd like to just walk you through the construction of that naive bootstrap so you get a sense of what you get out of the box for free without having to think. And then I'd like to convince you that you should think about what you're actually doing, and then we can do it. So just want to use an example from two different data sets from two different sources, one referring to Hawaii with 15 and the other referring to Hawaii with Hawaii. Actually, I think it's HI in Hawaii here. So during the naming phase, whenever somebody says, "Hey, you should go grab this data and work with it," you have to ask three questions, and you always have to ask these three questions about the data that you're about to work with. Who is giving you that data? Who's providing that data, as far as you know? what do they refer to that data set as, and when or what version of that data set are they providing you. And so you can just cheat by looking at some mod dates on the HTTP mod dates. And so by answering these three questions, whenever you see HI or you see Hawaii, you've actually contextualized that literal within the scope of these three levels. So here we grabbed two different data sets from data.gov, one being 1095 and the other being 4383, both of which talk about Hawaii. One refers to it as HI and the other refers to it as Hawaii. So once you've answered those three questions about the data set that you have, you've created the scoping, the naming scope for that HI by just appending all of the values within this URI pattern, where you start with a base URI, which is the namespace that you're going to be providing your data, and then you just take the answers that describe the source of the data set and version and tuck them into this pattern so that you have kind of a growing URI scheme, and the value HI is tucked all the way down here, so that if you ever toggle the source or the data set or even the version, then you're referring to a different URI, even though it's the same two characters that you find within the data file. And so this is nice because you get out of the box URIs and RDF, but it's not useful because nothing's actually connected. And so that's where enhancements comes in, and it's where it's critically important. The nice thing about using this kind of growing URI construction is that, as I mentioned, we don't have all of the time and all of the domain expertise that we want to sit down and do it right the first time. And so the enhancements are actually designed so that, and the URI design is designed so that you can incrementally integrate different tokens from different data sets by basically peeling away layers of the depth of this URI. And so here we can see the transition of HI going from the deepest URI depth up into Hawaii only according to data.gov, independent of all data sets, moving from data.gov's notion of Hawaii up to logD's notion of Hawaii, which this is actually an instance hub, Dominic's instance hub URI for Hawaii. And then we can go to a global context for Hawaii and reach into other linked data sources and refer to it in that, using that URI, or at least linking to that URI. And so we can't do this all up front right away, but as we work with the data set and we care about linking the data set to other data sets, then we can think within this framework of peeling away these layers of contextual depth to work towards having a common basis for referring to the entities that we're actually talking about. So this is jumping ahead to grabbing a slide from the advanced slide deck, but this notion of conceptual depth corresponding to the length of the URI, you don't have to work within a single contextual depth. And that contextual depth doesn't apply just to the things that you're talking about, like Hawaii. It also applies to the predicates and the classes that you're using to associate those entities. So in the advanced talk, TWed, I'll talk about cell-based conversion, which allows you to represent n-array relationships, statistical relationships that actually draws an association. So this is a 4 and 8 example where we say that in 2004 the U.S. gave this many zeros to Albania for child survival and health, and so we need to draw this many-array relationship. And so this URI has a very high contextual depth because it's all the way down to the single cell within that single file for that one particular version. And so that's where the red comes in. But we're mixing and matching global context URIs for RDF value. People recognize that. People recognize modeling ontology units. Jim McCusker is here. You can help me expand that acronym. But DC terms temporal is very, very common. not as global as our green LOGD. And so when you're looking at these handful of triples, you're seeing entities and the relationships between those entities existing at these different contextual depths. And so the key thing here is that when you do a raw conversion, all of your data is at the same deep contextual depth. Enhancement is about pulling out some of the relationships or pulling out some of the tokens so that you're referring to or reusing relationships that other people actually recognize. So, quick snapshot example of one of the rows for the two data sets that we named and retrieved. This one is actually just a listing of farmers markets in the country, and Hawaii has a farmers market called Ali Garden Marketplace, and that's the original tabular CSV file. And all of us have some degree of time domain expertise and semantic web expertise. And yes.
So that's a row.
Yeah, I'm sorry. Yeah,
Showing three lines.
It's a row wrapped 3 times.
Yeah.
Yes. So that's a visual artifact of me trying to fit this onto this aspect ratio. And so we have 2 routes. One route takes no time, no domain expertise, no semantic web expertise, and we can still get some RDF out of it. And the transformation here, so you got a Hawaii here, which was the first value. You got the Ali Garden Market, which is the second value. And you have very dumb predicates that associate the row itself to all of the values that the row actually contains. Now, these are called column 1, 2, 3, 4 because there was no header in the file. So that's all we know is that it was at column 1. But if there are headers within the file, then we mint predicates out of those URIs. So if the first one said state, the second one said name, and then town and zip code, then
But even if you had that, it would still be dumb, right?
it would still be, nobody else would recognize that URI because the point of raw is to make sure that we've distinguished from everybody else. Kind of the anti-integration.
So just a sanity check, the naming in the dumb thing, the DS4383, that's the data set, right?
Yeah, that's a prefix for the very long data set.
And then the 1367, is that the line number? That's the row
That is the
number?
row number, yeah. And we don't even type it here because typing it doesn't mean anything. And so even that is an enhancement. So, and later down in the slides, I'll show you, I'll actually elaborate on what this means to show some of the power of having the declarative enhancement parameters. But the other route here is we want something more like this. This is what the semantic web is about. The semantic web is about having resources that are typed to ontologies and vocabularies so people recognize them and can collect them. The semantic web is about reusing existing vocabularies. Here we have W3C's personal contact vocabulary that I can dig up the namespace for you. And that associates the farmer's market to an independent resource for the address that is typed to address and has the street, city, zip code, and everything else, all derived from these original values. And the semantic web is about having, and linked data is about having associations between the URIs for the things that you talked about and linking them, one way is with al same as, to existing URIs that other people already recognize. So we've now tucked this directly into linked data. And we've actually associated the dumb name for this 1367. We've associated it to a slightly friendlier, readable URI with con preferred URI, which does not have a domain or range, so I'm safe. Greg.
Was this just a typo in copy and paste? These are supposed to be the same row, right?
Oh, yes.
66 and 67?
I am dyslexic, yes. I'm not dyslexic, I don't think, but it appears so, yes.
Because none of those literals line up.
Aha! Thank you. Well, it's easier to go back and do this one. But, yeah. So, thank you. Absolutely. So I'll go fix that. But to get this takes some work, and it takes a mix of these three: time to sit down and do it, domain expertise to know that we're talking about addresses, and semantic web expertise to know that the contact ontology exists, to know that DC terms title and DC terms identifier and RDFS labels are good predicates to use. And so you really have this mix of all three of these skills. But this is what we want, and this is what the csv2rdf4lod can do. Yeah. So a laundry list, I'll skip to, and how do we do that? How do we get to that enhanced, well-structured, highly connected RDF representation? It's a matter of feeding this representation into the core converter, which is what the automation provides for you. So the automation creates a template that looks like this that you can tweak by inserting new enhancements directly into that template. And then this template is fed to the converter. And this embodies everything that is involved in constructing that new, highly connected, well-structured RDF. And so there's a cutoff here. I truncated my snapshot. But what we're actually doing is describing the data set that we haven't created yet. And we're pointing back, we're identifying it, just like we mentioned those three core attributes of who gave it to us, what do they call it, and when did we get it. And we're referring to the conversion process that was involved in creating what hasn't been created yet. And the conversion process just bundles a bunch of enhance that points to instances of RDF conversion enhancement, and then you pile on the enhancements here. And so the way that we get those OWL same as links is by just tucking in these four triples here, where we're pointing to some LOD link files and referring to the predicate within those LOD link files that we should use to basically implement a locally scoped inverse functional property inference from OWL. But this is, I have the two examples we can actually work with when we sit down and do this. So this is the RDF that gets fed into the converter that fully describes how to create that well-structured RDF. And then I'll just back up to the laundry list of, hey, there's lots of things that you can do that you can specify and how to interpret these things. Now, the enhancement parameters are modeled as closely as possible to RDFS and OWL. So if you see something that like domain, that's going to have the same notion as RDFS, you're talking about some assertions of the subject of the triple with respect to the predicate that you're talking about. So domain template, which should probably be called subject template, but describes how to construct the URI of the subject of that triple. The domain name gives you give it a literal value, and it constructs a URI for the class of that subject. Predicate and object allows you to do arbitrary annotations on those things. So equivalent property, subproperty of, are the OWL and RDFS. Conversion label is used to actually specify, derive the local name for the predicate that you create. Comment will just pass through an RDFS comment on the predicate that it hasn't yet created. And some property of duplicate. So there's just a handful of stuff, and you can modify the subject of the triple, the predicate of the triple, the object of the triple, or continue and add descriptions to the object of the triple, all based off of kind of a cell within the table. So, right. So I promised that I would expand this here a little bit to show the benefits of having a declarative representation on how the tabular data should be interpreted. So
Tim, I'm conscious that in the room we've got people who haven't done conversion, or really detached from it, to people for whom this is a review. We've got a whole spectrum.
Mm-hmm. Yeah.
And I'm worried about you sort of getting too far ahead of.
This is pretty much the end of it.
Right. Okay.
So
because it would be really sexy to show this live.
Sure. Yeah. So. And then we can fix the 1376 and 67 problem. So the point here is that we can always do this for free. We can get the raw, and we can sit down and take the time and the domain expertise to create the enhancement parameters. But once we have the enhancement parameters, it's free again to construct this out of this. And so now I can email you or point you to a version controlled representation of those enhancement parameters, and then you can just grab those enhancement parameters and apply them. And you can roll your own RDF without depending on anything but those enhancement parameters. So with that, we can go into hack mode, semi-guided, walking through actually applying these parameters.
I'm envisioning you actually kind of working through this, but for real.
Yeah, sure. Well,
something like this. Yeah.
Well, I've named it 4383, so I know where to dig it up. So I'll just start completely fresh. So at this point, you should be installing the converter if you haven't yet, because it's going to be pretty low, step by step. But
so, by the way, how many undergrads do we have here right now? Okay. So one of the projects that it's a high value target in terms of a research project is helping to create a visual interface to what you're about to see. Okay, simplified process, but a sort of a visual or a GUI-oriented way to do what we're about to see, so that somebody could walk up to it with the URI of a data set that needs to be converted or an actual CSV file and do what you're about to see. This is something we'd really, 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 really like to produce over the next few months. Extra bonus points.
The use case here is, I don't know, your professor or somebody says, hey, farmers market geographic data. And Dominic, do you remember this tweet that you send out?
Oh, yeah.
This is yours. You were like, I really wish I had the time to convert this. And I think it was 2:30 in the morning, and so I converted it. So I got a tweet that said, this looks like a really interesting data set. And so I think you pointed to this page. And so we have to go through the hassle of, finding out about the data set, which we already took care of. And then finally we have a download thing here. And so before we download it, we need to work through those three questions. Who's giving us the data? What do they call the data set? And which one of those data sets do I have? Okay, so DataGov is the person providing us this data set. They have the unique identifiers for how they refer to data sets, which is this 4383 right here. And so this is a unique identifier. They're giving us 4383. And then the version, if you don't want to think, you can just make a version for today, right? It's the one that I got today. But we can do a little bit better by checking the mod date on the file that we're retrieving. You could do things like hashing the file that you got and using that to name the version. So I'm just going to copy the link here. And I am at my desktop. So I guess I go a little bigger here. This will be fun. Should I go? Is it on the bottom of the screen okay here? Or should I raise it up?
Can everybody see that?
I'll raise it up. Is that good? That height? Because I need to see something, right? Okay, so I'm at my desktop and I've got a recursive directory of sorts, but that doesn't matter. All right. So the directory structure follows a convention that all of the automation tools assume, so that you don't have to continually feed it different information. That the information is directly there. So the data root is always called source, and this source is a directory that's going to contain a list of things like data.gov or epa.gov, and so our source is data-gov. By convention, we replace the periods with dashes for all of our identifiers to avoid periods in the URIs. Now, these values that I'm typing in right now are actually going to become part of the URI. So thinking through this up front has an impact the rest of the way down the line. So we're in the source directory, and the source is data.gov.
I have a question. So
Yes.
all of these directories that you're making should be directly under the folder for the converter, or they should be someplace else?
They can go anywhere. They can go anywhere. The data root, all that matters is that it starts with source.
Okay.
And you can have these sources everywhere for different projects or what have you.
Okay.
So all of the automation's built around that relative structure. So going to go into data.gov, and the directory in here is going to be the dataset identifier, which I'm really interested in this dataset, so it's 4383. So I'm just going to make 4383 and go into it. And so, gee, where am I? Oh, I'm in a data root, and I'm looking at data sets from data.gov, and 4383 is one of the data sets that they provide. So I'm going to go into 4383. I'm already there. Yeah. So inside of 4383, I make a directory called version. And if you remember that I was emphasizing these three critical attributes on how to name a data set and use the data set's name to contextualize all the values, is that it's source, data set, and version. And I'll make that point after I make the version. So here I am at version. I can make one for today, but I'm going to use the URL from the web. Here they have a copy link location. And one of the scripts is URL date, which doesn't give me one, so I'm going to fall back into September 28th. No, that's the okay. We will use today's date. So there's a make today version script. That would be, oh, it's off to the side here. So I just have a script that tells you what today's is conforming to conventions that we use. And that's just creating a directory for today and adding in another source directory.
So that's under version. So that,
Right. So the point of having a convention is not so that we can write dumb tools. The point of a convention is that I can hand you a data root and you know what you're doing. You know how to move around this thing, right? You know that this source thing is the root, and you know that I got some data from data.gov, and you know that data.gov calls this thing 4383, and you know that I called the version September 28th, 2011. I don't have to explain any of that. It's a convention that we use to facilitate communication of the data set that we're working with. So, three critical aspects are the source, the data set identifier, and the version identifier. But if you look at this path, you'll see that source is mentioned, and you'll see that version is mentioned. Shouldn't there be a data set that's stuck right there to be consistent? Absolutely. Short-sightedness on my part. But I'm working towards being able to handle that within the automation. So the data set's a silent data set, it's implicit. So I'm in this directory, and there's one directory here called source.
I have a question. So
Yes.
there's no real technical reason why you'd have to say, like you said,
No.
explicitly source and version. That's just to make it
It-
really human.
it would have been a
This is this.
Yes,
you know.
would have been a lot more obvious.
Yep.
But my focus was data sets. They're all data sets, right? So I just forgot to include that.
But that's why you did put those in there
Yep.
to make it really obvious that
Yes.
that's what you're looking at.
And this path here is actually going to lead to the same path in your URI. So the directory structure that you're working within on your file disk is the same path structure that you're going to work with in the URI scheme. And so to have that consistency is very helpful. And so I'm in this directory. I'm in a particular version, and I have a single directory that's empty in here. Now, this is what I've come to call the conversion cockpit. Cockpit because you should always be sitting here every time you do anything. Sit in, strap in, never move, because everything works from here. Except for when you do this. So let's see here. Is there... Yeah, so... except, always stay in your cockpit except for when you retrieve data. So here in the source directory, the point of the source directory... I'll back up one. You don't have to make these, because they'll just fall out of the automation.
So you're in source right now?
Yeah, I'm back in the conversion cockpit. I'm kind of setting up my cockpit, my dashboard.
That's along with.
That's what I thought.
Source manual automatic publish.
What was that script you used to do the date? I'm sorry.
It was so CR dash will give you all of the automation tools. So that'll give you your list of options. But it was CR make today version, and it should yell at me in it good. So all of these automation tools are contextually aware that they know they're not where they should be to run, so they don't and tell you where they should be run from.
It's spanking you.
It's pleasantly denying your request. So, and I want to hop back to the very beginning where I worked through this workflow. So you name a data set, and we haven't retrieved it yet. So we've just named it. We've named it by creating that directory structure. And after you create the directory structure, you go in and where was I going? Oh, jeez.
Well, you went ahead and created
Yes.
this other.
Yes.
Which you're about to retrieve.
Right. So as we plow through and do all of these stages, we're going to be spewing files around. Right. We're going to be retrieving files from the web. We're going to be maybe manually tweaking some files because the data they gave us didn't look quite right. We're going to be outputting some direct conversion results. We're going to be publishing those results. And so the conversion cockpit is set up to have to maintain a distinction on where we got the particular data files, the fact that we've actually touched some of the files, the fact that some of these files are automatically generated and can be regenerated. So the automatic directory is much like your bin when you're compiling code. And so the workflow here is you go into source and you download the original data file. And I'll go do that now. So I'm going to go into source. I'll use Jim's new. Do I still have the URL? Right. So maybe yeah, we'll go with Python. So instead of just grabbing the data file and having a file on disk, the automation captures provenance for free by just having a wrapper around the data download. So you give it a URL and it'll grab it, and it will grab the original data file, but it will also include a provenance file right next to that data file, describing that data file. So all you have to do is, instead of using wget or curl, use pcurl, either py or sh. They're two different implementations, but do one of them. I don't care which one. And so you can look into the file, which is actually like a zip or an Excel or something, which
Excel, or claim to be.
or you can look into the provenance file, which is going to have some description about the file that we retrieved it from. But you don't have to look in the provenance. It's just good to have so that you can offer it up to anybody that's looking at your results. So
This is where you got it from, when you got it, who you are.
Yep, and this is the Ferber stack that I mentioned during the meeting. So I backed up into my conversion cockpit. And the conversion cockpit is a versioned directory, and I've got these directories, and I put some data into source. The reason why this is called source is because it's what I got from somebody. Right? This is the source of what I'm doing anything about. And here we actually have to deal with a manual transformation because it's in Excel, and the dealing with Excel automatically is not implemented yet. We've got stuff hanging around, but if you want something to bang your head against, come talk to me. So the reality is that we can't just convert the Excel. And so this is a specific situation, an uninteresting situation, where you're going to have to manually do something. And the results of what you manually do goes into manual, because you can't reproduce that because you're the one that did it. You can't call a script and get it to be done again. Yes, it's easy to call a script. Scripts exist to transform Excel to CSV. We just don't have them sitting around in here. So I'm going to do the manual thing and open up the file. And it's always good to look at the original data to get a sense of what we're looking at. And just going to save it as a CSV. Now, so yes, this shouldn't have to be done because transforming Excel to CSV is uninteresting, but there are situations, there's always that niche data file that you're going to get, you're going to have to tweak something. And so we wanted to be able to account for that.
And you're going to put this...
I'm going to find my... How do I get to... Alright, so I'm just digging into my conversion cockpit, and then I'm going to save it into the empty manual directory. It's going to tell me usage, and I'm going to get out of Excel. So I have the original file in the source directory, and then I have the output of Excel in the manual directory, and it's in the manual directory because I was involved in doing it. We can't reproduce it unless you grab a mouse. So.
And git file is just a goofball name that they have, right?
Yep, that's the end of their URL redirected. So I'm in the conversion cockpit, and I have this file in manual. Going to the workflow, we retrieved it. We've adjusted it, and we saved our adjustments into the manual directory, and now we need to create the conversion trigger. You only create it once, and that's the thing that you always pull and everybody else would pull to get the RDF that you actually want, or that will be available to you. So the script to do that is this guy, and you point it to the input file.
So you're running that from...
Yeah, so now you follow the mantra, always do it from your conversion cockpit.
Right, so your conversion cockpit is one step above the source automatic manual.
All right, when you do an LS, you see all of your source automatic manual publish. So this script is going to look at that CSV and create a shell script for you. And actually spews it to system out, which we don't actually want. So I'm going to ask for it to write it to disk. And now I have the shell script sitting on disk. So you hop into your conversion cockpit, you pull your conversion trigger, and you get RDF. And we'll just do that. Okay, so what happened? Clear this out. The results should go into the automatic directory because code made it, so that's where things go. But only the parameters came out, not the actual RDF. And that's because I don't like raw conversions because they're not really useful. But for this situation, we want to actually show it. So one of the go-to scripts is crvars that shows you all of the shell environment variables. that are used to control the automation. And so one of the automation, so you can always run it and it'll show you the variables and their values and what it will default to if it's not actually set. And when you follow the installation process, you'll create a single file with all these environment variables that you can set and run from your bash RC. So here I have the omit raw layer to true because I hate raw conversions and I don't want them to show up. But I will set it.
They have some pedagogical value.
Yeah, but even though it didn't convert the raw, it saw that there were no enhancement parameters available and created a template for you within the manual directory. Now, the manual directory is intended, it only holds things that humans were involved with touching, not code. So it creates it here because you're going to be touching this and manipulating it at some point. And so I'll peek into that because this is the declarative representation on how to interpret or how to enhance your actual data set. So all of this template was created for you that you can then tweak. Here we have the data set URI for the data that hasn't been created. It's going to be the first enhancement, and it's typed to a void data set. It's typed to a layer data set, which is a subset of void data set. It has the three naming characteristics that I talked about: the source, the data set, and the version. And then it talks about that data set having a conversion process, which collects all of these enhancements. And so what it's saying is, I want you to enhance the thing at column 1. By the way, it has a header of this particular value. You could give it a label when it's commented out. You could add a comment to it. The crux here is range, which right now binds to RDFS literal. So all literal values are going to be cast to literal values, which isn't very useful. And so we can tweak this after we make raw. But even though it didn't convert raw, it still created the enhancement template for you so that you can start manipulating it. Actually, I could just do that directly.
I have a dumb question. What's wrong?
Yes. What's wrong?
What's wrong?
Raw is the naive bootstrap conversion that isn't connected to any data.
Pull up that one slide again. That slide you had.
This is raw.
Oh, okay, so it refers to that file.
That structure. This.
Okay.
Not much happened.
Mm-hmm.
There's all that raw contains is sort of no more information than the table itself. There's no semantics in that.
Right, it's representing a table in a RDFE kind of format.
Right, exactly.
Yep.
Ask questions so Tim can eat.
So I didn't pull the conversion trigger yet. I only pulled it the one time. And when I pulled it that one time, it refused to produce raw because the environment variable says I don't like raw. And it created the enhancement templates because they weren't there yet. And so now I can start manipulating that. So I guess one thing I do is just plow ahead and start tweaking the enhancements.
Well,
Or just convert the raw.
you're gonna. Well, if you could generate raw right now, I
Alright.
think that'd be useful. Just to, even though we sort of saw it, it would be useful to see it.
0 rows. Oh, right. WCSO.
Fill it up.
So when you have a higher resolution screen, the converter just outputs a report that it recognizes any of the enhancements that you've requested, and then it provides just a quick snippet about how it chooses to create predicates based off of the column headers. And so if we look into the automatic directory, we now have the file that we want, which is the raw.ttl. In the automatic directory, all files are still named to correspond to their inputs. so that it's really easy to just set side by side. Here's, this file went in and this file came out. And so when you have multiple files within your data set, you can keep track of which one goes to which. So here's the raw conversion. Everything is turtle because you should use turtle. And I in the slides, I actually cheated. I said column 1, but there's a random value there, and it mints a URI, a predicate URI out of that, which is this big long geographic coordinates for U.S. markets. So that's the first column. And so the first thing,
like the title of that table, and that's just it
was
in a
just
spot that made it look like a column header.
Yeah.
Okay.
So the first thing it does is outputs some quick descriptions of the properties that were created for this data set. And because there were no headers, it's just column 1, 2, 3. And once you Excel is really intelligent when it exports CSV and prints out 256 columns, even though the values aren't there. So this is some RDF that comes out of the first row. The first data row, the thing 2, so the second row is the file. And all of the empty values in the cells are now empty values of objects that describe that thing 2.
So could you, I know this is redundant, but just as a sanity check, could you...
Where's my data?
Could you open up the Excel again?
Yep. Yeah, just because you're going RDF doesn't mean that you shouldn't also refer back to the original structure, right? Because that's part of understanding what's
Right.
Yeah, so we don't get down.
So this is that first...
Yeah,
This is thing 1.
this gets the
or
first
what?
predicate.
Yeah.
Yeah. Now you can specify an enhancement that says header rows at 5, and you'll no longer get column 1, 2, 3. You'll get lock, add state, make name, lock, add strt as predicates. And I can do that in the first enhancement to show what happens there. And then the data row will just fall after the header. But if the data is separate from the header, then you can specify both, what it defaults to immediately after.
So that's the correct way to do it rather than what one would be tempted to do, which is the first time you cracked open that Excel, edit that out.
Right, yeah, and the entire objective of the automation and the conversion is that you should never touch any data file, because the second that you've touched it, it's not the same as what you retrieved from the government. And so the more hands that are in here, the harder it is to trace what actually happened. And so all of this is designed around you never having to touch it manually, or trying to minimize that as much as possible. So if I back up to thing 7, thing 6 here. We've got this Albertville Farmers Market, and that's under column 2, raw column 2. If I go back to the data, Albertville Farmers Market, and so these values are just like 86.2 in the X1 is column 6 here, 86.2, and so. I'm dying to make good column names out of this, and so maybe I can just do that as an enhancement. So, does anybody have a question about just? Well, I could point to the URI that gets constructed. So, does anybody have a question about how raw gets created? Just how to transform tables into RDF naively, not making them much more useful. So this DS4383 is a prefix that expands to this URI, where we've got the source data.gov dataset 4383, and then not the vocab, but there's a spot for the vocab too. And then into 2011, September 28th. So now that I have raw, I could try to create enhanced. And to make any data is just pulling the conversion trigger. And so I'll pull the conversion trigger, but it does some make type logic and realizes that making the enhancement would actually provide no more value than having raw because we haven't specified any enhancements. So it refuses to convert the enhancement because it would look the same as raw. So the way to do this is, so we got a header, it's a header row in here. All right. The way to do this is to dig up the wiki and refer to the list of enhancements. And so John was talking about having a GUI. This is the point where having an interface to be able to call upon the enhancements and say apply this enhancement to this particular column. Right now, I'm digging to a reference sheet. You know, I'm digging to some Java doc, which is outside of the system and not desirable.
If anybody's ever worked with some of the tools that are out there, like Socrata or Refine, Google Refine, or there's a couple others, they have a sort of a visual metaphor where you would sort of see the data in a tabular form, but you would click on a column header, and you would, and just as Tim said, what would come up is enhancement choices, and you could bind that enhancement to that particular column and kind of move on, and you'd sort of see this representation of the enhancement that you're trying to create, and then lock that away.
Yeah, but where we are now is digging up a reference sheet, and that reference sheet is this one page that is on the GitHub wiki for the automation, and I'm just digging up the structural enhancements, and I'm clicking on the header row. And so the header row, I have this example here that says enhance the thing at row 2 and make it a header row. And so I'm just going to copy that text and just plop it in here, change the 2 to a 6.
So does it know to scroll on down, to ignore 1 through 5?
Yeah. So you're saying everything above 6 is top matter, and that top matter actually gets encoded in RDF as a top matter predicate. It'll chew through the row 6 to make headers out of them, and then march down with the rest as data. If there's a hiccup between the header and the start of the data, then you have to specify a second parameter that says data start row. You could say header at 6, data start row at 10, and that little stuff just disappears. Mm-hmm. So just point at the, so in the automatic directory we have all this stuff for raw. We modified manual. We modified the enhancement 1 parameters for this file within the manual directory, and we just run the same conversion trigger. And when you run the conversion trigger, it sees that the raw are already available or that you don't want them, and then sees that the enhancements would specify better than raw conversion results, and then does it. So now we have E1 files within the automatic directory. The E1 turtle is that output. So go to thing 6. Oh, thing 7, right?
Is it? So it still is naming them based on the actual row number. I guess,
Um,
or is it redoing the naming?
well, yeah, so maybe I'm off by one.
So there's no.
So 116th Main Street. 116 Main. I'm down one, so I need to knock one off.
Okay.
So it's. So there, what it did is use a data row and minted predicates out of the data itself.
Yeah.
So all I did was change the same enhancement file, and I'm just gonna pull the conversion trigger, and it's going to replace the E1 files in the automatic directory. All right, so we've got thing 7, lock add state, Alabama, Mickett name, Alexander City, and these are just the headers from the Excel spreadsheet.
So what you've done is you've created property names that actually sort of mean something.
Well, they're derived from the header of the original data, so they mean something more than.
But those are reoccurring elsewhere now, though.
Yeah, so if I go to thing 8, thing 8 is a lock adder state, Alabama.
So with that one enhancement, you've created RDF, which is, although it's still, it only makes sense within the context of this file. It's more sensible than before. 'Cause you're
Right,
using-
yeah. Because you're reusing the implicit semantics of the original data file.
Right.
Now, this prefix E1 is different from the prefix raw. So, but the prefix for DS4383, thing 8, is still the same thing. So thing 8 now has call 1234 triples, and it has lock add state, market name, lock a dist triples. So we've doubled the number of triples that describe that same resource. So if we don't take the time to do any enhancements, we blow through and just create raw RDF, we're going to describe thing 8 within the raw predicate namespace. And then if people latch onto that and build applications or do analysis against that raw data, good luck. But if they do manage to do that, we're not going to break anything when we come in and apply an enhancement, because we're not changing those raw triples. We're just adding enhanced triples to describe that same subject.
So will they be able to take advantage of that at all?
Yes. So, so those triples will just show up.
The people that built off the dumb data will now be like, oh wait, this dumb thing also means this smart thing that lets me do
Yep.
all this other cool stuff.
So you'll just have more triples on that
Could you use
same.
Latin law, for example.
Yeah. So you have to guess which one's Latin long. I'm always terrible with that. But so we could do a couple of things. We could use domain name to type this thing to a farmer's market, which would have two effects. It would use an RDF triple to type thing 8, and it would actually rename thing 8 to farmer's market 8 to be a slightly friendlier URI. And so let's just do that.
I think X1 is lat.
I wouldn't use that. 31 degrees north.
Yeah,
Oh, lat.
I agree with
Oh.
that. Because if you think of Y as being up and down, right, that's north and south, and then
Yeah.
obviously.
You're just disagreeing with me by default. Which is a good choice.
So I'm just hopping into the enhancement parameters and uncommenting these 3 lines
This is what goes out.
to set the domain name to not tool. We want farmer's market.
There it is. Something north is the line that's running.
And then just hop out and rerun the conversion by pulling the conversion trigger. And so domain here is resembling RDFS domain. I'm typing the subject of the triple that comes out of one of the columns in the table. So automatic. So humans read URIs, so having Thing 7 is less useful than having Farmer's Market 7. So we actually changed the URI to give that little extra readability, with the trade-off of we're now describing a completely new URI. And so, but that new URI is typed to Farmer's Market. And that happened just by uncommenting these two triples. Enhance. So the conversion process has a new enhancement that has a domain name of Farmer's Market. And it applies to all of the columns. We could have done it, we could have added the domain name to column 1 or 2. But the subject that comes out of the triple that we derive from the column is going to have a domain of Farmer's Market. And then we associate Thing 7, the Farmer's Market, with a single triple that points you from the old URI to the new URI using the contact ontology from W3C, preferred URI. Yes, 3. And so Thing 7 was the old URI before we knew that it was a Farmer's Market, and it has a preferred URI of Farmer's Market 7. So we're trading off readability of URI with describing a new URI, but balancing that trade-off by associating the two. These used to be same as is, but we thought that was a little too extreme because we are manufacturing these ourselves. So, and same as isn't directional and preferred URI is. So, do you want to do a lat long since we were talking about it?
You know, you might as well do several. You do lat long and anything else you can do off the top of your head.
All right, so
State. You can do the state.
do we have consensus on? Yes, actually, I want to do state to do a LOD link. Do we have consensus on? Oh yeah, so one of the problems of not knowing where the header was when we created this template is that we don't have this cheat sheet of the header when we created the templates, and we never touched the templates after we created the first time. So we kind of have to backfill and count here. So 6 x1. What is x1? Is it lat or long?
The X1 was the minus 86
I
one.
think I disagreed with you saying it was X1 instead of
Are we right?
It was Y1, X1 and Y1.
So this is longitude, right?
I think this is longitude, yeah. Well, you'll be able to change it, won't you?
Yeah, tweak your enhancement parameters. So -86 for
I
Alabama.
think that's,
would be longest.
That's got to be a longitude.
yeah, that's longitude.
Yeah. It's not at the pole. So here I just added, I tweaked the range. I changed it from to do literal to XSE decimal. And I added in equivalent property WGS longitude. And so what we're talking about, what is equivalent property to longitude? Well, it's the predicate that gets created for column 6. And so this actually reads, enhance the thing at column 6, the predicate, and make it an equivalent property to WGS long. and that same property has a range of XSD decimal. Make it happen.
And do the same for 7, but
Oh.
flat.
And just always pull the conversion trigger.
Josh says.
Provenance.
That's right. That's right. And then when we enhance it.
Yeah, one of the frustrating things is that we have no way of capturing the provenance of how we make those decisions, what resources we have available to us. Oh, this one doesn't have it. So
Yeah,
it's,
some of them didn't have it. There you go.
well, actually one of the first enhancements that you should always do get rid of those silly empty values.
Oh, right. I was gonna ask you, how do you nuke the, what's the nuke the bogus entries one?
Nuking the empty values is a special case of interpret symbol. So you can see a particular symbol and pretend it's another's. So you can expand silly codes into useful values. Like I was looking at the White House visitor list. They have like WH. That's actually the White House. They have WW. That's actually the West Wing. West Wing has a URI on DBpedia. So you can just interpret WW to the URI of the West Wing. So.
West Wing and the West Wing.
Where are you modifying the White House graduates?
What's that?
When were you modifying the White House visitor list? Did you have like a demo something already, or?
Well, yeah, I'm using it for an example within my data quality paper.
Oh, okay, cool.
So do them.
And we have 8 versions of White House visitor list now,
Oh, cool.
consuming 6 gig of Patrick's SVN.
Let's use a
Do you
source
stay-
code control system.
Oh yeah, so
Archiving.
here we now have these typed XSE decimal. Don't complain to me that they're literal and typed XSE decimal. That's just how it serializes from Sesame. You can just get rid of all this stuff and just have the value within Turtle. And so the original value is gone. When you use equivalent property, you're completely replacing the original value. You can do a sub-property, and it'll preserve the highly scoped predicate, but also assert the WGS lat. And so let me. I'm going to replace the equivalent property with sub-property of.
I'm gonna do the other one too.
I'm just doing it for an example.
Oh, okay.
Well, actually, I want to contrast them. So equivalent property will replace sub-property of, will add in an additional triple. It'll add in the good triple next to the bad triple. Where's Cien? Cien here?
She was.
Cien, I'm only using 1 tab. You should yell at me.
That's much improved.
No, I need 3 tabs. Always 3 tabs. Okay, so we still have the lat long, but then lat and y1 still hangs around because it's sub-property. So what we're saying here is y1 is a sub-property of lat. We asserted y1 within the local predicate namespace that nobody recognizes, and then we sub-property that property into WGS lat, which everybody recognizes. But we don't want to have those hanging around because nobody cares about them, so we use equivalent property to just get rid of it. And so this is pointing out that all of the enhancement parameters are reuse the paradigm of RDFS, but cast within a literal to RDF instead of an RDF to RDF
So-
enhance
Can you,
inferences. Sorry.
Is there, can you use both at the same time? So say I wanted to say something that's like a DC term, but also at the same time say it's also an abbreviation if I cared about all the DC terms of an object, and also maybe what they also were and some other.
Can you do an equivalent property and a sub property?
Yeah, just put this.
I would. You should be able to. We could try it. I don't know if it'll fall out, but if it doesn't, then it should,
Okay.
because that makes sense,
Yeah.
right? You'd want to blow away the original and then tack in some additionals.
Yeah.
Yeah. So
so you do an equivalent property and then a sub-property? Right?
yes, you do an equivalent to blow away the original, the highly scoped predicate, and then tack on a whole bunch of sub properties to just keep proliferating that value. Yeah, and so much like when you compile code, you look at source code, you have the compile terminal, and then you have the run the code terminal. We usually fall into this 3-panel pattern where you see the enhancement parameters, and then you see the conversion trigger, and then the results of the conversion trigger.
In 2 years, we'll figure it out, then I can tell. See how he's got his terminal tabbed there?
So equivalent property and sub property of on the lat.
What are you doing? What do you
Yep.
add?
So it already works, Dominic.
Cool.
So farmers market 8, lat long, so lat 31, and FOF nose 31. So you would completely replace Y1 with WGS lat, and then use that same value by a subproperty of. So the enhancement parameters were this guy.
What does that mean?
Well, it doesn't. The farmer's market knows what 32.7 means. And 32.7 is a person. Is range of knows person?
Is it 32.7 hash or is it 32? Be careful, we got object 32.
No, this is a flash person.
Kingsley's not around, don't worry.
Yeah.
Its range is person, yeah. So yes, that works, Dominic. But so let's so this is so far all we've done is tweak what the subject URI looked like. We've cast some values to decimals. We've reused WGS lat and long. But what about when we talk about entities? Like we still have Alabama here,
Right.
and that was the use case in the slides. So for now, I'm going to keep that predicate. But I want to promote that Alabama to a URI. And so the way to do that is to say that the range of the predicate is a resource.
So slow down here. Go back and
So once you change the enhancement parameters, you pull the conversion trigger. The conversion trigger replaces the E1 output in the automatic directory.
You're going into Tim mode here. Hyperspace. You know, you just did about 5 things.
Oh, you didn't catch it?
There's one change to the enhancement parameter.
What did I do?
You changed the.
Oh yeah, changed RDF literal to RDF resource. Pulled the conversion trigger, and then we're gonna look at the results. And Loca.
The point I was trying to make is go back to where you chose that property to enhance.
I didn't, well, I mean, this is what I changed.
Okay, right. Right, so column 1 is the one that you're going to turn into a resource, yeah.
So instead of Alabama the string, make it a URI.
This is confusing because of the bogus, this
Yeah, it was
title
the-
being in there is sort of an artifact of the, it'd make much more sense if that actually said, right. So what this is actually going to do is, this is going to affect raw now. Is that
Nope.
correct? No?
You're only changing E1. So if you published E1 with that original string and then changed E1 and reconverted, you will then break somebody's application.
Okay.
When you publish E1 and you know that people are using E1 and you care that you don't want to break their stuff, then you make a third layer, E2, which describes the exact same Farmers Market 8 with predicates created within an entirely new predicate namespace. So it'd be E2 colon instead of E1. So let me dig that PowerPoint slide. We have Alabama sitting here. We know the scoping from the source, the data set, and the version. All we did was promote the value to a resource. So the only thing we know about it, well, we assume, which you can get around the assumption, but we assume that when you say hi, this version, and you say hi, next version, you mean the same thing. So hi is going to be independent of the version. It's going to be scoped by only the source and the data set. But hi in column 1 could be different from hi in column 2. And so it's scoped by the predicate name. So this would be Lauder dot whatever that predicate name is. Usually, but when you promote a resource, you don't want it to be named by the predicate that is referring to the entity. You want to refer to it by what kind of thing it is. So right now, Alabama is following this structure. It's a value of Lauder Stratter Alabama. We'd rather have it dataset 4383 type state Alabama. But when we do that, so we can do that, you wouldn't see much difference. It would just be a prefix change. But when we do that, we can also get these others, the two more important URIs for Hawaii for free. So I'll go do that now.
Are you doing lot link right now?
Yeah.
Well, it's 404 at the moment.
Mine don't.
Huh?
Mine don't, which is why I use mine.
Oh, you have it on your side, or?
rpi.edu/tilde-labat.
Oh, yeah, I forgot about that. But that's just for DBP, though, right?
It's DBpedia, GovTrack, and geonames. So I'm adding in the range name for state, which will, so again, modeled off of RDFS. I'm typing the URI that I created out of the value Alabama, and by doing that, I create it using this pattern instead of value of Lauder Alabama. And so that's already done with just by changing the range name. Then to associate this guy to these two more important ones, I just go grab the 4 triples from the examples page, links via.
So what's this gonna do? This is gonna shout out to,
All right, so I added these 4 triples.
this is doing lookup. This is-
So the enhancement parameters say, go grab these files. And well, we can go look at it. And here's a turtle file, and DBP's URI for Alabama has a DC identifier of all these things. In 15 Hawaiian is what we were talking about earlier. So the other part of the enhancement is the subject of DC terms identifier. And so what that is saying is that when you see the term Alabama in your data set, go query into this RDF graph, find Alabama, and whatever URI you mint up within your conversion, it's going to be the same as Alabama. So then search for the subject of the predicate that you specify. And this is a scoped inference. It's a local version of OWL inverse functional property. Or just a really dumb lookup, whichever one you want to, however you want to think about it. So after specifying that, pull the conversion trigger.
Done.
Did she say dumb?
Done. So we don't see any difference here. Farmers Market still has, it's type state instead of value of lot or something Alabama. So that follows the new, slightly nicer URI scheme for naming Alabama. The same as triple falls down later in the file because the sequence of these assertions are actually by design so that you can focus in on the meat of data that falls out of the CSV row. So I'm going to look for this thing. Nope.
Here goes the
No joking.
800s.
There. Oh, I'm gonna search for same as. And that typed Alabama
Ah,
has a DC identifier of Alabama, and it's same as DBPD, GovTrack, and GeoNames.
and voila, we have linked data.
Ta-da!
Yeah. Right there.
And so, I mean,
We actually had it before.
this centers around needing LOD-link files, which is really just a marketplace for the collection of the identifiers scoped within a particular domains and the popular URIs that should be used for those identifiers.
Why did we only get it for Alabama?
Because it only needs to be asserted once.
No.
The other ones will be down further in the file.
Yeah, I mean, if you want California, Alaska, Arizona, Arkansas, California.
Yeah, but I thought each of the things was a row.
We're still referring to Alabama within our local highly scoped URI and only asserting one triple between our local UI for Alabama and LOD-link
Oh, well, so
and LOD-cloud.
so what you're saying is, where we're not seeing it, those are whatever
Is-
state is before Delaware or whatever, and there's no need to reassert those?
Oh, yeah, like,
There's multiple farmers markets in Alabama, multiple farmers markets in whatever.
right, but you only assert the triple ones, the same as triple ones.
Yeah,
And so once you try to assert it again, it doesn't matter.
That's what I'm saying, so it's unnecessary. So 1148, 1149, those could be farmers markets in Delaware, but we don't care, we're not going to reassert. We have that one assertion.
Right. Because triples are sets, or elements of sets. Yeah, so
Right, so.
that's the cut of it. That's the simple stuff.
People should ask questions, or if they've got specific things that they want to see, they should ask for those.
Really, the questions come out of looking at your own data and trying to think about how it should be modeled, and then looking to the enhancement parameters to specify how to get what you want to come out of the process.
If you replace the log linking, if you uncommented the log linking, then would you be replacing the URI for every stanchion inside of that row as the URIs you're referencing? So instead of having our own URI inside of every row that we have inside of our data set, it would actually be one of those triples for all three of those.
So you're saying in
So instead of inserting it once, in your enhancement parameter, you did the log link. I know I've done it because it is how we do the other, but I don't remember the exact. I don't remember the exact enhancement when we use. But I do instead of making this the assertion once for every row, it replaces the URI promoted to the one I'm wanting to link to. So I don't ever see my main URI. I only see the one I'm allocating as to. Or I'm usually, I take that back. I'm usually doing it from the actual. I'm doing it now same as from the subject to the other URI as well. So it's an enhancement on the
States and territories?
Yeah. Yes.
this is what you're doing.
That is what, I know.
Where
what
is
it?
it?
I know that it is.
Well, I don't know what you're doing. So what do you?
Oh, I'm replacing one of the rows, or one of the columns that says like EVP, and I make that as an L same as instead, and then instantiate that this subject that I've created in this hub is also an L same as to this other URI that is EVP, and any other ones that I didn't care about. I have done in the others. And at the same time, this. That's just the primary topic. No, it's a similar idea. But it shouldn't be there, it should be further on down.
We hear
That's creating URI down.
Domain-
Down.
we're talking about renaming thing 8 to Farmers Market 8. But all of that is still contextualized by that deep, long URI. Domain template gives you full control on how to name that URI. So if the thing that you're, the rows are very popular things, you could just directly refer to those using the template. And so this template will get expanded with particular values to name the URI within LOGD, instead of having thing 1, thing 2, or state 1, state 2. But I was going to dig up your input, which hasn't been edited. Does Google let me just type in
Yeah,
states?
you can search for it. It should be like instance of state or something.
Hey, Google works.
It's amazing.
So this is the input that that Dominic's working with. First column is just the name of the state. The second column is the URI. DBP does URI for that state, and then 2-letter abbreviation, FIPS code, and then a variety of alt labels, which can be comma separated or semicolon separated within a single cell, so that you only have to specify one enhancement. But
Yeah.
and then on SVN he has these enhancement parameters, that says the domain template is going to be expanded with the period is the value of the current cell. So the value at column 1. So state 1 would be, yeah, so you would take this value, fill it into that template, and construct LOGD's instance hub URI for Alabama. Does that get us to what you were saying, Dominic?
Well, I was asking,
Yeah.
is the way through the log link, is the way to actually replace the thing that wrote, it's not necessary, I guess. So say if in one of my columns, I have the FIPS number, and I want to do a log link to, not to PD since I already have it, but, one of the other ones I happen to find, the log link file to geonames or something like that. And I wanted to include it inside of there for the actual row to have it with everything else. So I wouldn't have to do like a double link to be able to find it. I could just have it there with everything else. So the way I could create a new URI and the same, almost like it was like a new column inside of that row.
So
I would have to have this.
Are you just saying that you would prefer this to say DBpedia Alabama instead of having random URI that we minted up?
Yeah, and then having that.
And then having that same as.
Yeah.
We talked about it at length.
Yeah.
In the semantics of al same as, it doesn't matter,
It doesn't.
right? But then when you're dealing with non-inference, just direct RDF, you have a level of indirection. But that level of indirection, we actually want to maintain because we want that insulation on how we are interpreting Alabama and Alabama directly. Because when we're saying that the state is Alabama, we're pretty sure it's Alabama. But we still want that level of indirection for somebody else to contest one same as triple within our data set and not the 50,000 triples that we did if we directly asserted DBpedia. And we'd also have to do 3 same as triples, or we'd have to locad state to all 3 LOD clouds.
Yeah, but that's different than the scope of what
We're getting flagged.
Hub is trying to do. You mean, like, if I understand for other data sets, well, it's outside of
10 yards.
It's outside of the scope of this conversation. I guess
But-
normal data
so-
sets,
so-
I agree, but not with.
Yeah. So that was, so you got 5 yards for addition, but we're not shutting up. But 10 yards for bogarting the next presentation. So anyways, that is more of an advanced kind of thing. But there was one question I wanted to ask that actually is relevant to using Google spreadsheets. Is a really handy way for people to hack around and play with this. And I wanted to confirm that you can just use that as put that into your pcurl and pull it down. Is that correct? What form of the URL do you want to use?
Right, so the automation will accept this key value and then just strip out the CSV from Google using pcurl. It's not pcurl directly, but
it's in the documentation about how to do. You have
Yep.
that as an
So-
example in there.
Is that in the documentation?
I think it is.
Do you have documentation on the two source or the retrieve.sh now?
yeah.
It ought to be in the
Yes.
documentation because we use it all the time.
So automated creation of a new version data set. So I'm just gonna grab this script.
Am I my own source?
You are your own source. Oh, I don't want that. So you just grab the key from the URL.
Google to source. There you go.
Now this is automatically setting up the version directory for you. So it created the September 28th. It created your conversion cockpit. It grabbed the data file from Google, put it into the source directory, and it didn't create anything in automatic because I hate raw conversions.
Right.
If I had that part on, it would do it automatically.
Wait, you hate...
Raw conversions.
Oh, okay, I just wondered, because I don't think you've said that before.
What's your position on raw conversions?
So I'm gonna...
This becomes a resource.
just do my own. And I'm going to move the enhancement parameters to the global position. And then blow away the version that it created. This is what you put on SVN. You put the retrieve SH,
Right.
which encapsulates where the data is, where it sits,
Yeah.
and then how to interpret it once you've applied it, or once you've retrieved it. And then you just run the retrieval. He'll download it again, set up the shop with its own version, and still didn't. It should have.
Yeah, that's great.
A minute before deadline, and then I croak.
So do you have, sorry to move on to another topic, but just to finish. Do you have documentation that goes through a live example like what you just did?
Yeah.
It says step 1, do this, step 2, step 3, step 4, step 5. If you want to do this, then all that kind of stuff, what you just did.
His GitHub documentation.
Yeah, there's 200 wiki pages that I pour documentation into. Yeah, just I have more wiki pages than issues, than unresolved issues.
Oh, good. That's,
I think 37 more issues, and I'm gonna have a problem. I'm gonna either have to write more documentation or, fix a bug. But
there's a fine balance there.
There's a lot of pretty detailed steps.
so, and if something doesn't make sense or doesn't answer your question, let me know, because that's how I focus on the documentation, answer your question into the documentation. And so yeah, this fetched the Google spreadsheet, saw the enhancement parameters, and converted it.
So that's, now if we dive in there, we should see the enhanced.
All right, so this states is our nobody recognizes URI thing too. And I've got an AL same as DBPD Alabama. DBPD Alabama did not come from a log link file. It came from just a value within the table. Just this, it just took this value, made it a resource, and so you're just using the equivalent property, making it a same as, converting that thing to a resource, and you get a same as triple directly because it's encoded in the file itself. But most government data is just referring to it like these.
Right.
So the instance hub is a special case where you actually have the URI
Right.
within the data value itself.
But one of the things that kind of comes out of this is by really understanding login files, you can simplify this sort of thing, kind of eliminate some of the work that's required to do.
Well, that's exactly what Instance Hub is.
Well,
The whole marketplace of log link files for different categories is exactly what.
Right, so where I was referring to my 3 log link files on my home directory at RPI, I would just add in a 4th to his. Do you have DC identifiers?
Yep.
Yeah, so then it just falls out. And if not, then I say subject of whatever predicate he's using, and then both work together.
So I think it's 9 o'clock,
Yeah.
so I think we'll officially,
I think it's 2 after beer o'clock.
we'll officially say thank you to Tim.
Everybody at once, 1, 2, 3.
Thank you, Tim.
Thank you. And so.
This is better than